Here we have electrolysis. Now there are two uses for electrolysis in the edXL exam. We're going to look at the first one here, only the first one. And this again is separating stuff. So how do we separate things that are joined together? Now essentially, electrolysis is you pass electricity through things, and because of the electricity is passing through it and the equipment that we've got, they separate out. So passing electricity through salt, which is sodium, metal, and chlorine gas joined together. So the table salt that we eat is actually half metal and half a gas. You join them together and you get table salt. Now, if you could separate them, you'd obviously get back your sodium and you'd get chlorine on its own. But how do we separate them? So remember, table salt, half metal, half gas. You join them together and you get table salt. If we want to separate them back out into sodium and chlorine, how do we? So for electrolysis to work, the stuff that you're trying to separate has to be dissolved in water, so it has to be a solution of some type, or it has to be like lava, which is what we call molten. So that's something that's heated to the point where it has become a liquid, like lava. Lava is molten rock, so that's rocks that are so hot they have become a liquid. So you need to get whatever you want to separate. It has to either be dissolved in water or so hot it's become a liquid. Now, we could perform electrolysis on glass, but only if the glass were melted and in a molten state. You can't perform electrolysis on solid stuff. So to perform electrolysis on glass, you'd have to make the glass liquid, and that takes a huge amount of energy and a very high temperature. So, very key point, electrolysis doesn't work on solids because stuff, and the technical word is ions, need to move. Now here is a little example. You've got your negative electrode and your positive electrode, which is essentially prongs into the solution. You've got your test tube, in this case, to capture the gas that comes out. You've got your electrolyte, and you've got your power supply, which is the electricity that goes through it. Now I'll explain a few more things about that. Now here's a much simpler drawing. You've got your power source, which is electricity. You've got your electrolyte again, which is that liquid or the molten liquid thing that you're trying to separate. You've got your negative electrode, which we call a cathode, and we've got a positive electrode, which we call an anode. So those are the prongs that you stick in the liquid. And here's a third one that looks exactly the same as the first one. In fact, it probably is. Now, key words here are electrolyte. Now, the electrolyte is just simply the liquid we are separating. Okay, so it's either the hot stuff that's turned into a liquid or the dissolved stuff. Now, it has to be dissolved in water, and we call that aqueous, or like lava, which we call molten. Solids cannot be separated using electrolysis. Now, there are some words underneath that are quite important. Inert. Now, this is an important word in chemistry, and it means it doesn't react with anything, so it won't change. So it's very important that those electrodes, those prongs, those anodes and cathodes, are made of something that is inert, that doesn't react with the liquid that they're dropped into. Otherwise, that would make everything wrong, and it wouldn't separate anything at all. It would just mix more stuff in. So inert means it doesn't react with anything. Now, the anode and cathode, which are electrodes, the prongs, or the sticks that you put into the electrolyte. Now, the cathode is negative, and the anode is positive. Now, electrodes are usually made of graphite because graphite conducts electricity and, very importantly, is inert. So graphite from your pencil would be perfect for an electrolysis prong, and in fact you can set up an experiment at school using pencils. Now, graphite will conduct electricity, and it is inert. It doesn't react with anything. It's quite a weird material. So within the liquid, anything that's positive in the liquid will go towards the negative electrode, the cathode, and anything negative in the liquid will go to the positive electrode, which is the anode. Opposites attract. And that's the very basics of what you need to know.